This is Twit.
Bandwidth for Know-How is brought to you by CashFly.
This episode of Know-How is brought to you by the Ring Video Doorbell. With Ring, you can see and talk to anyone at your door from anywhere in the world using your smartphone. It's like caller ID for your house. Go to ring.com/knowhow and get up to $150 off a Ring of Security Kit with their limited time offer. On today's show,
We're going to start building an oscilloscope with Smitty.
welcome to Know-How. It's a Twitch show where we build, bend, break, and upgrade. I am Father Robert Balaser.
And I'm Brian Burdett.
And for the next 30, 40 minutes, we're going to be showing you one of the things that we've been playing with so you can take it home and play with it on your own. Brian!
Padre.
This is actually our first show of the year in the studio.
That's right, because everything else we have done was pre-recorded.
Or on the road.
Or on the road, yeah. We just got back from CES.
We did. And actually, I need to ask you this because typically the viruses that you would get at CES take about a week to incubate. And the best way to get rid of viral material is to incinerate it. So I'm wondering, how do you feel, Brian?
I feel fine. A little anxious now that I see the flame next to you.
Hold on. Wait. I can make that a lot bigger. There we go. Oh, I'm sorry, what were you saying?
Fortunately, no, I don't think you need to burn the bacteria off of me. I got all of my sickness out in December, so...
Evidently, this year was pretty bad. There's, on the Twitters, on the blogs, there's people who are saying, like, they're just down.
I guess so.
Completely knocked out.
Maybe it was because this was my first CES. I had, like, the newbie luck, and I didn't get sick, but
is that how that
feeling
works?
okay.
So you've never been to CES, so there's, like, a force shield?
Yeah, I think so. It works that way, right?
Yeah, I think so.
It's like when you play roulette for the first time and you accidentally put too much money down, which I totally did.
Do you want to tell them that story?
I lost.
We'll save it for.
We'll
save
that.
When you meet Cranky Hippo in person, ask him about the roulette at CES story, because
I learned. I learned things. I learned how to spend $20 really fast.
really fast. All right. Before we jump into it, I do want to mention one thing, because this literally happened about 8 hours ago.
What was that?
And that is, remember Lily, the company that made 2 years ago announced that drone that would follow you and launch on its own.
That got super hyped.
Super hyped. A lot of people bought into it.
There's a couple people here at the studio that bought.
There's two of us. There's myself
and Anthony Nielsen.
Yeah. It's dead.
Dead.
Yeah, so Lily sent out an email message to everyone who had supported the project. Basically said, look, we've gone through our ups and our downs. And I understand them on this. I mean, it was new technology. It worked, but there were always some issues that they were trying to get rid of. And unfortunately, in the 2 years since they announced it and got all this hype,
competition has caught up.
You've got DJI and at least 3 other Chinese companies who have made something similar at a lower cost point, and they can actually be bought now. And so Lily read the writing on the wall, and they're like, no, we're done.
Because I think they had 34 million in pre-orders, but fortunately, if you did back it, you will be getting your money back. Isn't that what they said?
Yes, because remember, this wasn't a Kickstarter or an Indiegogo. They did it through a separate financing company. And the money that they had to run the company, so to build it up, actually came from VCs that they had brought in.
Okay.
So if you pre-ordered a Lily, you should be getting money back on your credit card or PayPal, however you paid for it.
Yeah, I know. When I first saw the video, I was skeptical because it worked in a way that it was like, I see there being a lot of hurdles. Like we do have drones now that will follow you, but it was also waterproof.
Yeah.
And it was supposed to be something where you just, hey, it's paired to my smartwatch, and I just throw it in the air and that's it. And I was like, I don't know if it's going to be that easy.
The Lily was foldable, but I mean, it was still this big.
Yeah.
So
now
you
that
need a backpack, they literally had one I looked at CES.
Oh, really?
That fits in your shirt pocket.
Whoa.
And it's, well...
Yeah, oh, a different drone.
A different
drone, right. Because even the DJI Mavic will fold up, and that's pretty tiny.
Yeah, so...
That's too bad. But at least they did it right where they're going to refund some money. Because
I'm sure some people are going to get shafted. They're going to run out of money.
The one that I always think of, because a little bit near and dear to my heart, I didn't back it, but it was the Scully helmets, the smart helmets. Yeah, and nobody got their money back from that.
Cool idea, but a lot of these companies underestimate how much money you need to get to market.
Yeah.
Lilly didn't do that, and I will give props to their management team. I know there will be a lot of people who are ticked off. There's going to be a lot of snide remarks, including from me. I'm going to do a couple, but they tried. They really, they honest to goodness, they put money into the technology. They hired the right people. They didn't go crazy and buy an office building in downtown San Francisco. They tried to slow the burn rate. And when they finally had something that was working, they looked at the price points, they looked at what the market was, and they're like, look, if we had this 18 months ago, maybe, but it's too late.
I think it kind of goes to show, because there has been this Kickstarter, Indiegogo kind of explosion over the last couple of years, but it shows how difficult it is to make something, to manufacture something on like a big scale. Because even, I forget his name, we've had him on Twiat before, but he made the shield.
Oh, right, Daniel Ayub.
Right, and he was explaining to us that he really wanted to make that product, but that when he went to the manufacturers, he didn't have any leverage.
He had no clout.
Right.
Yeah. And you know, again, that's a good example of someone who did it right. He did his homework. It's not like he said, oh, here's a project, let me get money, and then we'll try to make it. He had a completely drawn out plan of how much it was going to cost per unit, when he'd be able to get it. And the problem is he's not Dell, he's not Apple, he's not Compaq, HP. So the manufacturers, literally, after receiving all of the plans, after tooling up, after getting ready to print, they said, yeah, no, we're not going to be able to do it for the price you said. We want 40% more.
Right.
And then after that, we want 20% more. And then it was, okay, we've printed up half, but now we want another 50%. And it was one of these things of...
He already had the pre-order costs and everything. There was no way he was going to be able to put in more money.
So goodbye, Lilly. Thank you very much. And it's not going to be the last time we'll hear a sad story like that.
No. But as difficult as it is to manufacture a product like that, we're going to try and put something together ourselves today.
Yes, we're not doing any of that sneaky made in China with factories that will try to mess us up, because we've got something better.
We're our own laborers.
We did, and we've got the man himself right here is going to show up, Mr. Smitty Halibut, Mark Smith.
Hey everyone, how you doing?
Smitty.
Hey, Smitty, how you doing?
I'm doing okay. How you guys doing?
All right, now we all three of us got back from CES.
But
yes, it was also my first time.
Well, see, and you didn't get sick either,
and I did not get sick,
so I guess there really is a force field around new people.
Right, but we never were able to meet up while we were there either, which kind of
I tried. No, we tried.
We got close. But we did. We also went to the Hack 5 meetup, or I'm sorry, the Tech Thing meetup.
Tech Thing with Shannon and Patrick.
But you left, I think, 30 minutes before we got there.
Yeah, it's not my scene. It was way too loud to be able to talk to anyone, and I would love to hang with Shannon and get to meet Patrick, but Patrick was kind of holding court. I mean, like you do when you're the host of a show that's doing a meetup and whatnot, and it just, I love the people, but it's not really my scene. So,
well, it was fun to hang out with everyone, and I was disappointed that you weren't there. But I think it was like around 9:30. I was like, wow, getting really tired. Like this place is kind of hopping already. And then midnight rolled around, and that's when like really everyone showed up.
And then at 1 o'clock, we're like, we better go home. And like, Brian, you got a flight in the morning. I have to go back to CES.
Right. And I was still recovering from the hot and juicy restaurant that we went to. Smelled like garlic.
Oh, the crabs.
Everyone at the bar knew
you guys got crabs.
Had hot and juicy.
Hot and juicy crabs.
It's garlic butter.
Well, that was the thing. Like we had our little bubbles that nobody wanted to come into because of the garlic smell. So it was a buffer zone.
I had to go outside just so I could stop smelling myself.
You have that problem even when you don't go to hot and juicy.
Kind of sad.
Well, TMI.
But Smitty, we're not here to talk about my bad hygiene or bar scenes. We're here to talk a little bit about a project that we can make. I actually sent you the link for this yesterday. It's an
and I
oscilloscope.
purchased it because for the price, it is kind of an amazing thing.
Yeah, Alex, if you could actually go to the link, this is what we're talking about. This is a JYE Tech. It's a DIY digital oscilloscope. This thing is $23. Okay. Seriously, if you've got even a remote level of soldering skill, you can put this thing together. and it teaches you a bunch of components.
Okay, so the price is good. I know I want to build it, but why?
Good
what does
question.
it do?
Smitty,
Yeah.
why would I want an oscilloscope? What does it do for me?
So the oscilloscope is a piece of test equipment that allows you to watch a voltage as it changes over time. So you're familiar with what a voltmeter does. You put the two probes on, you put one of them on ground and the other one on a test point that you want to see what the voltage is. And you might see that number change, but that number changing, it's only telling you what that voltage is at that time. And you can't really, it's difficult to look at that changing number, and they only update every, few times a second or whatever. And it's difficult to see what's going on that line. Is it oscillating? Is there some noise on there? Whatever. An oscilloscope shows you the voltage over time, and it actually draws a graph as it goes across the screen. So it allows you to look at signals as they're traversing through your circuit, and that can help you debug things, can help you design and validate that it's doing what it needs to do. Or if you're hearing some distortion in an audio path, you see your sine wave go up and it flatlines and then it goes back down again, well, you're getting some distortion, and you can kind of poke at different parts of the circuit and see what's happening where. And that's what an oscope does.
Exactly, and this is one of those fundamental pieces of equipment that I've always wanted. But the oscopes, when I was growing up, back in the 20s,
they had electricity then?
They were really expensive. They were really, really expensive, especially since you had to have someone behind it holding a candle. And,
yeah, right.
No, but I mean, you had these massively expensive and actually really, really big pieces of gear so that you could get the cleanest signal possible. Because the thing about an oscope is an oscope cannot be introducing any of its own EM into the signal. Otherwise, what's the point?
Right.
It's got to be totally clean. It's got to be really, really well done. And that meant it was really, really expensive. But with the advance of technology over the last
100 years.
Thanks, Brian. I appreciate that. Over the last 100 years, it's come down in price. And so here's what we've got. Now, Smitty, I know you ordered one of these. We are not going to finish this project today, by the way. Smitty's going to help us go through some of the basic parts. We're going to show you a little bit of soldering.
A little bit of crying.
Probably a little bit of crying. I actually ordered 3 of these because I'm almost positive I'm going to blow at least one of them out. When you order the kit, actually, we're going to put her in a little handy dandy. I love our little vase here. You got one of these, right, Smitty?
I did, yeah. I just bought one just earlier this year.
Oh, these are so handy. I love them. So let me spin this. This is what you get. So out of the bag, all of the traces are done. Some of the more difficult components, the ICs, are already mounted. So all you have to do is follow the instructions, although the instructions are really kind of weak, in the bag. And this becomes, if you go back to that link, Alex, this becomes that. They do include a case, which is right here. So, it's not just a bare board. You will be able to, once you've assembled everything, put all of that into this little case right here. So this is cool. Actually kind of cool. I'm very much looking forward to it. Smitty, you saw the instructions online. Did they make sense to you?
Actually, I haven't looked at the instructions yet. I was foolish and bought it anyway.
Amateurs look at the instructions.
Amateurs.
I would not say that.
No, amateurs look at instructions before you buy the thing. I look at the instructions when it comes time to assemble it. But
yeah, I will say this is not for a rank beginner. If you've never done any soldering and if you don't know what components are and how they're different, maybe try an easier project, because what they're assuming is you'll be able to read the symbols on this board. Because if you look at the board, you actually get the symbols for what each component should be. And if you don't recognize that and you don't know which way to put the component into, you're going to run into problems.
So this, as far as like a 1 to 10 scale, 1 being the most basic beginner and 10 being expert.
This is like, I'd put this 3 or 4. It's not super hard, but you do need some basic knowledge. I mean, if you can solder without burning through the board, you can assemble this.
If you know which end of the solder to hold. If you smell chicken.
Stock images here. Insert stock image here. Yeah.
If you solder and you smell chicken, you probably shouldn't be doing this project.
You're doing it wrong.
You're doing it the wrong way.
I mean, this one, because they did all the surface mount stuff for you, even though I contend that anyone can do surface mount, if you've got the right tools, fine tip soldering iron and some tweezers, you can do surface mount. But these are all through hole, and like Padre said, really the only difficult part is just making sure you got the right component in the right place, and that's more of a reading the instructions, and a well-written instruction will make it very clear what component goes where, at least for the first few. Yes, thank you. Yes.
Ow!
Do not hit the soldering iron there.
Actually, okay, there's a couple scary things about this. One, okay, there's the way that she's holding the soldering iron, and obviously she's very, very calm. She's not looking at what she's soldering, which is also a problem.
Right.
And she seems to be soldering a battery. Like, just for some reason. Not really sure what's going on there, folks.
But she does have safety glasses on, so
she does, so it's all okay.
Yeah.
All right. Sorry, what were you going to say?
No, go.
What I'd like to do is I'd like your help, Smitty, because I mean, it comes with this little bag of components. Bag of parts. A lot of it's really easy to figure out. I mean, the pin headers go onto the pin sockets.
Don't do those yet, though.
Yeah. Look at
wow. What a mess.
Making a mess.
Oh, look what I did. All right, so let's take a look at some of these components, and you can tell me what they do. Switches are super simple. We know what the switches are. So they got micro switches. We've played with those a lot.
Those are buttons, not switches.
Oh, sorry. Those are buttons. These are switches. We've got our power connector. We've got our, this is where the signal is actually going to go. So it's a little barrel connector, BNC, that's going to allow us to hook up to our probes. But then we start getting into the individual components. We know LEDs. Yes, we kind of know resistors. But then, Smitty, I get components like this.
Capacitor.
So tell me what a capacitor is.
Okay, so a capacitor is a device that stores a charge. It is one of two devices that stores a charge. This one happens to store an electrical charge. The other one is called an inductor, and it stores a magnetic charge. But let's stick with the electrical charge. And what that means is, as you start pushing current into this thing, it will store that, and it will start building up a voltage, and it tries to keep the voltage across its pins constant. That is to say that if you put a higher voltage on those pins, it will pull it down until and it sucks current in when it's doing that, and then it's slowly builds up a charge. And then if you take that voltage away, like the voltage source away, the voltage on those pins will stay there. And so you can measure the voltage across a capacitor that's been charged up and pulled out of a circuit, and it will still have that voltage across that charge. Then if you put a load on it, like a resistor or a light bulb or a motor or something like that, it will slowly start putting out that charge. You can think of it as like a little tiny battery, rechargeable battery, except the curves and profiles are very different than normal batteries. But it stores a voltage in there and can supply it later. Those are probably going to be used as filters. So the idea is you've got a power supply that's putting out like a 5-volt charge or a 5-volt source, and your circuit sometimes needs a little bit of current and sometimes needs a lot of bit of current. And so what you do is you stick a capacitor on your voltage line, and when your circuit's not using a lot of current, that voltage will go to charge up that capacitor up to the 5-volt or whatever it is that your source is. And then when your circuit all of a sudden needs a lot of current really quickly, normally, if you did that without the capacitor, the voltage on the power supply would start sagging and it would drop down. Right. Instead, that capacitor tries to keep it up at that high voltage, and it will start giving out some of its stored charge to keep that voltage up. Yeah. And so it's a way of making sure that your power supply lines stay at the voltage that they're supposed to be at. And it's kind of a little local reservoir. In the ubiquitous water analogy for electricity, think of it as a bucket. Right? You pour a bunch of water into the bucket, and then the level raises up the bucket. And then as you start drawing some water out of the bucket, it starts going down. Does that make sense?
Oh, absolutely. And people have been talking about this as if it's a battery. A lot of people are actually making banks of capacitors to use as really, really fast charging batteries. You could push a lot more current into one of these than you can into a lithium-ion battery, and you can do it much more safely. Now, this one is rated for 16 volts. It looks like 100 picofarads. What does that mean?
Microfarads.
Microfarads, sorry.
Thank you. So the farad is the unit of storage. Most circuits, you do actually see whole farad capacitors these days. They tend to be very large or very small and very low voltage. But usually we're dealing with things in the picos, nanos, and microfarads. That's kind of tends to be the usable range. It's just how much storage, how big is your bucket, right? How much charge can it hold? Sometimes you want a small bucket if you're only trying to filter out high-frequency stuff, but you want to let low-frequency stuff go through. Sometimes you need a really big bucket if you want to have a lot of local storage.
Right. When I'm using these capacitors, you'll notice, like on my LEDs, if you go to the side view here again, Alex, one end is actually longer. Do I have to worry about positive and negative on this?
On that particular capacitor, yes. So that is an aluminum electrolytic. You'll also note that there's a white stripe on the side, and the white stripe has a dash in it, or a minus sign. So these are polarity sensitive. The aluminum electrolytic capacitors, the big cans like that, one side is positive and one side is negative. If you hook them up backwards, you will have a bad day. They will start leaking the goo that's inside of them, which is a very nasty goo. You don't want to do that.
Yeah, busted caps. So the shorter lead is going to be my negative. It's going to be my ground.
I can never remember lead length designations. I always look at the package.
Got it.
There's a negative side. What really drives me nuts is that the capacitors are marked with the negative side, but the boards are marked with the positive side. You will always see a little plus sign next to the pad that you put the positive side in. It drives me nuts. I don't know why the industry does it that way, but they do.
So this is one of those projects that you really shouldn't do late at night, because you're going to miss one of those and then you get blue smoke.
And have a bad time.
One thing to note is that not all capacitors are polarity sensitive. Why don't you hold up one of the little kind of tannish disc capacitors?
One of those.
So you got all of those all over the place.
So small.
Those are ceramic disc capacitors. They are not polarity sensitive. There is no marking on which one is positive and which one is negative. They can go in either way. The difference between the two is the chemistry inside as to how it actually stores its charge and what it does.
That's interesting. So, actually, I did not know that. I did not realize that some caps were insensitive to polarity.
Mm-hmm. Most of them are, actually.
Those little disc ones, they'll just collect charge and then release them in the polarity that you charge them in?
Correct. So,
so
a capacitor is just two plates that are standing right next to each other but are not actually touching. There is no DC path across a capacitor. So there is no wire that connects all the way through. It is literally two plates of metal right next to each other with some sort of a gap in the middle that keeps them from touching. And that gap in the middle is called a dielectric. It can be air, or it can be some sort of a material like a thin film or a piece of glass, or the phenolic on your circuit board can sometimes act. So if you've got copper on the bottom and copper on the top with the phenolic in the middle, that will act as a small capacitor. And so and the ceramic discs are literally a disc of ceramic with metal on either side and leads coming out of them. There is nothing inherently polarity sensitive about that style of capacitor. The aluminum electrolytics are the dielectric and the stuff that they kind of immerse the whole capacitor in. The chemistry is very specific, and I think you have to have different metals on either side of the dielectric. I can't remember the details, but it ends up being polarity sensitive. Electrolytics and tantalum are the other type that are very polarity sensitive, but almost all others are not.
All right. So in this kit, actually, if you go to the overhead, I don't know if it's in the shot, we've got three different types of caps. So we've got these, which we've already talked about. Those are the larger ones. These are the 100 microfarad. Then we've got the two separate types of disc capacitors. And obviously, the larger one has a larger capacity, right?
That's not always the case, but
really?
In this case it might be, yeah. And in fact, you want to look at the numbers on those and make sure that they're actually all the same.
Oh, but these don't have
so the numbers on it will be something like 103, which is 10 times 10 to the 3. So it's kind of like a resistor coding.
So the big ones say 104.
Are they all 104?
It looks like it. Looks like they're all 104.
This supposedly should have a complete listing of all the parts that are contained in here. So I should have at least, theoretically, no, they didn't tell me about the caps.
Okay. Well, so the big ones are all 104, it looks like. And then the little ones, one says 121 and another one says 22 on it.
Okay. So we'll look at the little ones in a bit. But the 104s, the way you read that is it's kind of like a resistor where you have two digits that specify the two most significant digits of the value, and then the last one is an exponent. So 10 times 10 to the 4th.
Right.
So that ends up being 100,000 picofarads. And all of those numbers, ceramic discs are always measured in picofarads, even when you need a really big number. So it's 100,000 picofarads, which, do the math, ends up being 0.1 microfarads. 0.1 microfarad caps are very commonly used for decoupling caps. The power supply caps I was talking about, you'll typically have a large electrolytic at the power supply itself, and then you'll have those little tiny 0.1 microfarads right next to where it's needed. So as close to the chip as you can get it, or as close to the circuit that's using that power as you can get it.
I love that. This is all this insider information from a person who's actually had to assemble these and build these boards.
And design them.
And design them. All right, so we talked about caps. I think it's natural that we talk a little bit about this. If you go to the side view here, it looks like, to the untrained eye, that looks kind of like a cap. It's got the same sort of shape as that larger one, but it's not. Tell me about inductors. What is this? What does it do?
Okay, so in the way that a capacitor stores an electric charge, an inductor stores a magnetic charge. Did you ever wrap a wire around a nail when you were a kid and hook it up to a battery and use it as like an electromagnet? You ever done that?
As a kid, I did that like yesterday.
Okay, well, perfect. So what you did is you made an inductor. And so what an inductor is it is a coil of wire. Just like the capacitor was two plates of wire that were close but not touching, the inductor is a coil of wire. And that coil of wire sets up a magnetic field. Right-hand rule, if your current is flowing this way, your magnetic field goes this way. And as you set up a coil, all of your right-hand rule magnetic fields will go through the center and then back around out and then back in the bottom. And so all of the magnetic field that's set up by this current flowing through this wire is all going in the same direction, and you make this magnetic loop. And that magnetic field kind of works on itself. As that magnetic field is there, it actually induces it induces an electrical charge in that wire. And so it's kind of this circular thing, not circular in the form, but the current going through the wire creates a magnetic field. The magnetic field then induces a voltage on it. And so if you put a current through an inductor, it will set up this magnetic field. And then if you take away that current, it will try to continue pushing current out the wire. And this is actually why are there any relays on this board?
No.
Okay, so a relay is an electromagnet hooked up to a switch, and so you can use the electromagnet to move the switch back and forth. But it's an electromagnet, so you've got this coil in there. You always put a diode, facing the other direction on the coil. So if this is the positive side and this is the negative side of your coil, you always have a diode pointing up. So positive is going to hit the top end of that diode and not be able to conduct. So normally it's not going to conduct anything. But as soon as you remove voltage from that coil in the relay, it's going to try and continue putting out current in the direction that current was flowing. And so now, but if there's no path for that anymore, it needs a way to dissipate that current. And so it'll go through that diode and back into the coil until it all dissipates in the internal resistance of the coil.
Let's talk about those diodes, because we've actually got two. There are two different sizes of diode. And actually, when you do get this kit, what you want to do is they've got a little sheet here. Let's put it on the side. And you can check off all the individual components. So go through the kit and make sure that everything is in there. Otherwise, you're going to get halfway through your installation and realize that they're missing something, and then you're no bueno. But these are the two different types of diodes that are included in these kits. Smitty, what do these do? Oh, by the way, for the inductor, do I have to worry about positive and negative?
I am not aware of any inductor types that are polarized. That one certainly is not, because that one is literally just a coil of wire wrapped around a slug of iron or a slug of ferrous material that increases its efficiency. So that one, no, I don't think you don't have to worry about that one. The diodes are very polarity sensitive. The whole point of a diode is that it allows current to flow one direction, but does not allow it to flow the other direction.
Mm-hmm. And are those voltage sensitive? I mean, are these rated for voltages, or are they rated for current?
So a diode, so you lose a certain amount of voltage across a diode. It's a semiconductor. It's a transistor, or it's not a transistor. It's a simplified version of a transistor. Transistor has 3 fields. The diode only has 2. That's why di2. It has two triodes, or two. What the hell are they called? Odes. What are they? I'm blanking on the term. Anyway, it's got 2 leads coming into it, right? And one side is doped positive, the other side is doped negative, and it allows current to go one way but not the other, and I can't remember which one's which. It doesn't matter. So how are they rated? They are rated for the amount of current they can pass, and they are rated for what it's called forward voltage drop. If you put a positive voltage on the anode side of the diode, and then it will pass current over to the cathode, but there will be a fixed voltage drop. It's not really fixed, but there's a voltage drop of about 0.7 volts. Some diodes have a lower voltage drop of like 0.5. I think shock keys can get down to about 0.5. Light emitting diodes They are diodes. They only pass current one direction, just like the silicon diode you've got there. Their forward voltage drop is usually around 2.2 volts. Some of them are around 3 volts. It depends on the LED. So the forward voltage drop and the amount of current it can pass are typically how diodes are rated.
Right, and we were actually talking about including a couple of those in the Aquabase project that we did, because we had a problem with our really cheap power regulators and the really cheap Arduinos where they were feeding, if you powered it off of a standard power supply, it worked fine. Right. But if you tried to program, it actually wanted to feed USB power back through the power supply.
Oh, yeah.
And so we just rigged up a quick disconnect because that's all we had. We didn't have any diodes. But we could have put a diode in there just to make sure that the current only floated it. It only floated it in one direction.
Actually, you want 2 of them because you don't want it to go the other direction either. You don't want your power supply to feed power into your USB port either. So you want to make sure you have 2 diodes. They're called power mixing diodes. I do these on all of my designs as well. So you've got power coming in from USB through a diode to your main power bus. You've got power coming in from your external power supply through a diode to your main power bus. And then any other sources you can do in there. And whichever one happens to have the highest voltage is the one that will be providing power to your circuit.
All right, let's talk a little bit about power because we've got 2 sets of components that really help us. This is the stack O resistors.
Wait. No, some of these are not like the others?
Yeah. So folks, what you got to do, and actually if you go back to your handy dandy little sheet here, you will have, where is it? Resistors. You will have a list of all the resistors that should be in here. You have to make sure, there they are. All of these are inside your kit, and I am not good at this, so I do need a picture representation of what they are because they are all rated, and you can tell by the bands. Smitty, do you have your bands memorized?
I do.
Really?
So hold on. That's not even what I was talking about. Notice how some of them are a blue background and some of them are a green background?
Oh, yeah, of course.
I have never seen a green resistor. Go look at your parts list and see what the green ones are.
It's called a
I'm sorry.
choke?
Those are chokes.
Those are chokes. Those are inductors.
Oh,
really? A choke and inductor are the same thing. The only difference is how you use it in the circuit.
I get to put it in my inductor pile.
Yes, you do.
Those
are organized.
Ooh, okay. So let's go from the inductors and the resistors to these. I've got 2 regulators. What are regulators?
Those are regulators? Those look like sockets.
No, these are actually regulators.
Oh,
no, those are sockets. Sorry, where are my regulators?
The TO92
just got called out.
I know.
Pin header. Yeah.
They're probably
I've got a bunch of transistors
TO92s,
here.
the transistors. Check those. I bet you those are the regulators.
Those look like...
Okay, the larger ones. These are the regulators. Sorry, this is in the wrong pile. Get out of here.
Those are sockets.
Yeah.
Well,
no, those are all transistors.
Just transistors and regulators, and they look nearly identical.
No, they're slightly different. Actually, that's a
package.
good question, Smitty. How do I tell the difference between my regulators and my transistors?
Go look at the numbers. If it's a 7805 or 78 something, then it's a voltage regulator. You can put a full-on circuit inside a little TO92 like that.
Okay.
It doesn't have to just be a single transistor.
I can't see anything.
It's going to be on the flat side.
I need like a microscope to be. Oh, wait, there we go.
You need someone with younger eyes.
79L05.
L5, that's a regulator.
7905?
It says that there's 2 in this package, and there's a 79 L05 and there's a 78 L05 or
okay.
05.
So the 7800 series are positive voltage regulators.
That is
the 7900 series are negative voltage regulators. I'm impressed. So this is that's what the inductor is for. Okay, so it is taking a single voltage source, probably 5 or whatever volt you pass it, and then it is using a switching power supply to generate a negative rail. So you're going to have a positive voltage supply and a negative voltage supply, and the 7905 is going to be your negative 5 volt regulator.
Okay, so don't just willy-nilly plug these into...
Absolutely not.
Yeah, because they have like specific model numbers.
What's the worst that could happen, Smitty?
Well, you let out the magic smoke and you go to your second kit. That's why you have 3, right?
Now, of course, we know what an LED is, and we know how those work. We've talked about those on the shows before. Right. We've also got these pots, so I can do adjustments.
That is not a potentiometer.
This is not? Wait.
It's a capacitor trimmer.
Wait, this is a cap trim?
That is an adjustable capacitor. Yep, a trimmer cap.
You are just blowing my world, Smitty.
I believe the green ones are 10 puffs, PFs, picofarads, or are they 20 puffs? They're somewhere around there.
It says 5 to 30.
5 to 30. Okay, so that's a 30 puff adjustable cap.
I didn't even know they made adjustable caps.
Well, yeah, because switch back to me, please. So remember when I was saying that capacitors are two plates that are right next to each other, right? And so all that is a screw that moves one of the plate closer or farther away to the other one. And the distance between those plates is what adjusts the capacitance of that capacitor. You can also do it by increasing the area, but that's a little bit harder to do. But by moving them farther apart or closer to each other, you can adjust the capacitance of that capacitor.
By the way, Smitty, I should mention that while you've been talking, Brian has been displaying his brain-melting GIF from Indiana Jones.
Yeah. I was the
Oh.
Indiana Jones like melting.
Yeah.
Yeah. I mean, I'm learning a lot.
But see, that's
But I'm also like.
This is why we wanted Smitty on, because you could actually get this kit, and without knowing what anything does, if you followed the instructions, you could assemble it. But it's better if you know what the actual components do. And actually, you know, Smitty's teaching me things that I had completely wrong, that I would have screwed up. Yeah. The last component here that's not a socket, a switch, or a button.
Some other mechanical.
The crystal.
A crystal.
Crystal. Tell me about. We talked about these crystals when we did your clock project, your steampunk clock.
Oh, yeah.
But what does a crystal do?
So a crystal is kind of like a capacitor and kind of like an inductor. I'm going to wave my hands at a bunch of math, but if you hook up a capacitor and an inductor in a certain way, the capacitor tries to store up an electrical charge, and it will provide a current that will charge up the magnetic field in the inductor, which then ends up causing a voltage, which will charge up the capacitor, which will create a magnetic field, which charges the inductor, and it goes back and forth, and it will oscillate back and forth between these two, and you end up getting a higher voltage and a lower voltage, blah, 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 right? And so you can make an oscillator, and an oscillator is something that generates like a sine waveform, or you sometimes square waveforms. It creates a signal. And the problem is that capacitors and inductors are not very precise. You have to have very finely tuned values to get a specific frequency. And as it heats up, the things expand and they change their values and stuff like that. So having an LC, an L is the inductor and a C is the capacitor, having an LC oscillator is not very precise. Enter the crystal. The crystal is a circuit that kind of acts like a inductor and a capacitor in what's called a resonant tank circuit, except that it oscillates at a very precise frequency.
Isn't 14,000 hertz?
14, it says 14.000.
So, something, oh, let me see what this one is.
If that one says 14.0, then it's going to be a 14 megahertz.
Oh, no, this is 8.
8 megahertz. Okay, so that's an 8 megahertz crystal. And so if you just put like a transistor right on the outside of it to give it some feedback and some other hand wavy things, it will output a 8 megahertz signal. Pretty strong, and but very precisely 8 megahertz. All right, even if it's not if it's not accurate, it will be precise. It'll be the frequency won't change very much. I don't know what the precision on those things is. It might be like 7.995 or 8.005 or whatever the precision value is. But it will be. Whatever the accuracy value is, but it will be very precise. It'll put out that one frequency and that one frequency only.
Right, and remember, because an oscilloscope allows us to see a signal over time, you need something that can accurately track time, and that's what they're using the crystal for.
Sense.
Also,
As
Burke,
he's
pointing out that we need a test device. Actually, we got that too. That's a separate kit that we're going to be making. So this is going to allow us to test our oscilloscope to make sure that it's actually measuring properly. Of course.
What is that?
Do they have a tester for the oscilloscope tester? And
that's an oscilloscope testing kit?
Yeah.
I'm curious what it is.
I got it from Banggood. It was the same thing. It just allows me to test. Okay. I can push certain signals to my oscilloscope, and it should look exactly as it does.
It should.
It should.
Quotation marks. Yeah.
Of course, if I'm assembling it. Yeah, exactly.
Calibrating these things is always hard because your calibration is only as good as the precision of the device you're using to calibrate it. But then you need to calibrate the device that's doing the calibration. Who's going to watch the watchers of the watchers?
Who calibrates the calibrator, Smitty?
Yeah, I don't know. Black magic voodoo.
And actually, that's probably
Tektronix,
that's one of the more important, more difficult things to do with an oscilloscope. A really high-end oscilloscope has really, really good calibration. I mean, it's timed perfectly. It's a $23 oscilloscope, so
You're not going to get very much precision.
But we'll have fun doing it.
We will have fun.
We'll have fun doing it, and it will be incredibly useful because honestly, for the kind of stuff that we're doing, you don't need that kind of precision.
Nope.
I'm not going to be, doing gigahertz level stuff, right? I don't need a tech scope. I can get away with the, I'm doing stuff a little bit more intense than you guys are. So probably like the $400 Rigol or Regal or however the heck it's pronounced. The DS1054Z, I think, is the one that I'm looking at. It's about $400 and it's a 50 megahertz scope and it is very good. It's 4 channels, lots of good stuff, but it's $400. This one is $23. You're still going to get some useful stuff out of it. I think this one is good up to 200 kilohertz.
Yep.
Which is great for any audio project. That's well above. I mean, that's a whole decade above what most audio stuff is.
If you just want to see what your audio signal looks like, or like we did a lot of stuff with PWM. If you actually want to see what a PWM signal looks like, this is something that will do that incredibly cheaply.
Cool.
Yeah.
All right.
No, this will be great. I'm looking forward to getting mine.
Okay. Now remember, folks, we aren't going to finish this today. We're going to start. Hopefully, Smitty can come back and help us finish this project. But we wanted to show you if for $23. And the cost of a decent iron, you could assemble something that is incredibly useful.
Yeah, definitely.
Yeah. And when we come back, we're actually going to take you back to CES really quickly while I start soldering some of this together. And then Smitty is going to help us set up because we need to know how we're going to set up our iron. We need to know a little bit about how we're going to start mounting this before we go to the next episode. But before we do that, let's go ahead and thank the sponsor of this episode of Know How. Hey, Brian.
Yeah?
You were at my house in Las Vegas.
I was, yeah. Had a good time.
Did you notice something about the front door?
I noticed that there was a security camera.
There was. Yeah,
I felt watched as I approached the front door.
And you should have, because I was watching you. Actually, I installed one in your room, too. Did you see the doorbell in your room?
I was wondering what that ringing was in the middle of the night. That was a little frightening, yeah.
Folks, of course, we're talking about the Ring Video Doorbell. It is a piece of gear that I bought before they became a sponsor on the TWiT TV network. And what it does is simply marvelous. It replaces the doorbell that you have and it gives you a smart device, one that is capable of two-way communication. Do you want to see who's coming to your door, even when you're not there? Do you want to be able to have a conversation with them? Maybe to tell the delivery person that, yeah, you can leave a box under the planter, or to tell them to come back later. Do you want to make sure that shifty folk aren't coming by your house every once in a while?
Stealing your power?
Or stealing your power, yeah. Do you want to make sure none of that happens? Well, if you do, you owe it to yourself to get yourself a Ring Video Doorbell. Now, this is what the kit looks like. Inside here, when you're dropping my variable caps, you're gonna find everything you need to get this thing up and running immediately. It includes the doorbell, the mounting plate, and all the tools. Once you have this installed, you can install an app on your mobile device, and it will allow you to see immediately whenever someone pushes that bell. When they push this, you'll get the nice little tone that says, hey, come answer the door, but it'll also activate the high definition camera and microphone. You can see who's come to your door and you can push a button on your phone to start to talk to them. My parents use this all the time, even when they're not at home, even when they're halfway around the world, because if there is someone with nefarious intent, they'll think someone's in the house. And boy, will they be surprised when you say, hey, I don't know you, get away and stop plugging your stuff into my power sockets.
Or like we just got through the holidays, if a delivery driver comes up and doesn't know where to put the package, you can say like, please just leave the package. I need that. Just hide it behind, the plant right there.
Precisely. It is a good way to stop burglaries before they happen, but beyond that, it's just a nice way to turn your house into a smart home. Now, they've got these brand new ring of security kits that use their advanced motion detection technology to protect your entire property, not just your front door. Their kits are going to include a Ring Video Doorbell and a solar security sign. They may include a stick-up cam, solar panel, or chime. Now, the Pro kits have a slim video doorbell Pro with crystal clear 1080p HD video and night vision, and it's hardwired, so you never need to charge it. Now, the wireless and weatherproof HD stick-up cam keeps an eye on other parts of your property and allows you to hear and speak to visitors with two-way talk. You can plug the chime into any standard power outlet to know when you have a visitor, even if your phone's in another room. So they really thought this through. They've also got an illuminated solar-powered security sign that will deter intruders before they get to your door. I mean, they're going to go for the lowest hanging fruit. The Ring Video Doorbell and stick-up cam install in just minutes, and working together, they provide 24/7 monitoring of your entire home, whether you're in your bedroom or thousands of miles away. You can also connect your Ring Video Doorbell with your favorite smart locks and hubs for added convenience, monitoring, and security. I trust my parents, their safety, their home, to the Ring Video Doorbell. I think you should too. Join the millions of homeowners who protect their home with Ring. For a limited time, Know How listeners can get up to $150 off one of their Ring of security kits. Just go to ring.com/knowhow. That's ring.com/knowhow. And we thank Ring for their support of Know How. Hey, Smitty, we're going to take a quick break. Can you stay with us and guide me through the start of assembly?
Absolutely.
All right. But before we do that, while we were at CES, we were in the press room. We were helping Twitch, Patrick Norton and Ryan Shrout, do a little broadcast from the show. And then I sat down with Patrick and I asked him for his musings on what he saw at CES 2017. We're here at CES in the press room just above the South Hall, and I am sitting next to this paragon of man here, Mr. Patrick Norton. That's right.
Paragon of man.
There's some bro love going on, but there's also some great tech. Patrick, we've had some time now here at CES, and we've seen the shinies.
The shinies.
The shinies, the techie
so many
things.
shinies.
And I think we can start to discern a couple of trends, some of the things that keep coming up over and over again.
The 2 terabyte hard drive from Kingston. It's a thumb drive that holds 2 terabytes. It looks like it fell out of the toolbox of the Millennium Falcon. Clunky.
Okay.
Does not begin to describe it.
That is an example of the shiny. I love the shiny, but I want more than the shiny. I want to see the products that are actually starting to push us down a path that all the other manufacturers are going to follow. You heard a keynote at the start of the show,
right?
That kind of was a shove. It was an electric vehicle, but not an electric vehicle that most of us might identify as the thing.
It's been a really funny week in the sense that cars have been a big part, or car manufacturers have been a big part of CES for years and years and years, right? Starting with car stereos, and then the car manufacturers are here, and of course autonomous vehicles are the next thing. And now we have the opening keynote, slot number 1, the thing that determines kind of the whole rush of the show for the rest of the week was Fiat Chrysler. Yes, with a concept vehicle.
The portal gun.
No, the portal, which is, well, I know what you're thinking, right? Yeah, millennials, they want a portal gun. They're going to teleport to places. This is fantastic. It's a minivan.
Okay.
It's an electric minivan, right, which allows you to basically, push out, maximize the space inside of the volume. It's got really, really cool, like the front door slides this way, the back door slides this way. It's got barn doors on it. If you've ever wrestled a refrigerator or a small child into a car, you know why that's really awesome. But it's also really funny because it was, they had like 4 picture-perfect Abercrombie and Finch, except with more, skin-covered models up there who obviously didn't have children or even know what children were, basically being the examples. But the idea behind the Chrysler Portal is to explore the possibility of what a family transportation vehicle could look like for the millennial generation as their lifestyle evolves.
I love that. That's the PR copy. Now, here's the thing, though. Even though that sounds kind of cheesy, and even though we may not look at that as a great example of an electric vehicle,
it might be a great example of an electric vehicle, but it was because it's basically you can stuff a bunch of people in it. It's really easy to get into and out of. It's electric. It's got a 250-mile range. It's got a quick charge to get you like 150 miles in 20 minutes of charging. So there's a lot of stuff. The big thing is like a lot of people were like, oh, Faraday's here, and like Faraday's had a rough year because as near as we can tell, they're out of money. They've lost a bunch of executives. They're probably never going to finish the car,
their tech doesn't quite work right. It's shiny, it's great, but I mean, in practice,
a friend of mine that covers electric vehicles is basically it was so much smoke and mirror, even worse than the one they did last year. And what makes that really critical is like they're trying to be a boutique manufacturer making supercars right at the time Ford went, we're going to invest $4.7 billion because we finally think it's time to build electric vehicles. And when Ford says it's time to build electric vehicles, it's time. It's time, right? They're there, and at the same time that's going on, oddly enough, they flipped the switch on the assembly line at the Gigafactory outside of Reno.
Yeah, a little bit of pressure.
That
Push Tesla, along the way.
Panasonic project. So, and it's what's crazy is when you look at the number of buildings that have been finished at the Gigafactory, there's like 3 buildings done. There's like another 27 to go. Yeah. So part of me is like,
a lot.
Cheap lithium-ion batteries. Yes, yes, yes. And that will also not just be important for electric vehicles, which are obviously starting to grow in a big way, because we need to get the cost of the batteries down and the cost of the motors down. Because, a friend of mine was like, oil companies totally killed the electric vehicles. No, a family in the United States typically has $40,000 a year in income. So if they're looking between a $25,000 gas vehicle and a $40,000 vehicle that is exactly the same except it uses electricity, guess what? They're buying the gas vehicle. So if we bring those prices down, the Gigafactory should be able to do that.
Yeah. Now, EV cars are here to stay, and of course, we've got the central hall with some beautiful screens from Samsung. They're touting their quantum dot technology.
Yeah,
we've got LG with their
everywhere.
W series, which it's literally 0.62 inches thick.
Yeah.
It mounts on a wall. But the other trend that I was interested in was an assistant in everything. And by assistant,
goodness.
I mean Alexa. Alexa has won the assistant war.
Well, it's Google Home may have a presence at CES. It's just going to be next year.
Yes.
I mean, Amazon Alexa, over 7,000 skills
GE
now.
has Alexa. Samsung has Alexa. LG has Alexa. Everyone wants to have some sort of assistant that becomes a hub. And they may call it different things, but it's the idea of a hub that centers around your home entertainment or your refrigerator or whatever it might be.
But not just hubs, it's also the devices, right? You know, Samsung's coming out with a new, robot that'll respond to, Alexa voice controls. LG's Smart Instant View refrigerator is a fully functional Alexa device. Dish is going to bring Alexa voice control to Hopper. The Samsung, it's the PowerBot VR7000. That's the vacuum. You can basically tell your vacuum to heal or attack or whatever you tell a vacuum to do when you're talking to it. Except, most people who talk to their vacuums have issues that aren't involving, arguing it around. Alexa's everywhere. Everywhere you turn around, like our product works with Alexa. We're bringing Alexa online. Alexa is important to us. Alexa controls being in, I want to say, Linksys's Velop.
Yes.
So you can be like, Linksys, turn on guest network, and then get credentials for somebody who's coming into your house. Oh, random thought. I've been thinking that all of the mesh networking devices that I've been looking at, whether it's Eero or the Velop or
get rid of the dead spots of Wi-Fi.
The Netgears box. I mean, I've been thinking they all run on the same chip. They are all running on Qualcomm chipsets.
Yes. Well, Qualcomm's kind of won that battle.
Now,
there are other trends here. We are seeing much more IoT, but also, and I like this trend, we're seeing security for IoT. There's more companies that are coming out saying, look, we have to actually protect these devices. It's a little smoke and mirrors right now, but I have hope. I live in hope. I think maybe the other big thing about CES this year has been the fact that what we're seeing, there is nothing that has just exploded and caught our mind as this is
brand
very
new. Evolutionary year.
But it's a good
Little
evolution.
changes here, yes.
I like what we're seeing.
The quantum dot technology and the new 4K panels looks absolutely fantastic. I'm a little over the panels getting thinner. I mean that LG flat panel that's like 2.3 millimeters
attached
thick.
to the wall.
But it's like they're sitting there in the presentation and we've discovered that you have to have less than 4 millimeters of depth on your monitor to truly create an immersive experience because that eliminates the shadows and blah 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 blah. And then we got the guy that made Kylo Ren's helmet to develop our sound bar, which you're going to need to plug in the HDMI and the power.
It's
this big fat squat thing underneath it.
It is.
Dolby Atmos is showing up in a lot of the sound bars this year and a lot of the televisions this year. You mentioned the security devices, Norton Core, not me Norton, but Norton, the security company. That's in pre-order, also using the Qualcomm chipset that everybody else is using, but or a Qualcomm chipset. That's interesting because it's going to be like $200 if you pre-order it, $280 if you buy it after it starts shipping. But then it's going to be like $109 a year for 10 licenses, and a license goes on any of your computers or phones in the house to protect them from malware, which hopefully it will actually do.
Well, Patrick, if they want to find out anything else about the coverage that we've done here at CES, what they need to do is they need to go to twit.tv/specials. They can see the entire special, and they can also find you. Where do they find you these days?
Well, of course, I do This Week in Computer Hardware with Ryan Shrout. We just recorded an episode here at CES, and of Tech Thing, TEKTHING, which is the show, or techthing.com, TEKTHING, which is the show I host with Shannon Morris.
Thank you so much for your time.
Pleasure,
it's always fun to see you, brother. And back to you in the studio. By the way, everyone who wears a virtual reality headset looks that cool.
Right? It's even cooler when you put little googly eyes on the outside of them.
I want to put like little OLED screens and just have the eyeballs.
Right.
Like
look
it's
around.
an actual scan of your
point
eyeballs.
in different directions and blink independently. Yeah.
Right? See, I have great ideas.
That's the future.
I have the best ideas. Really.
You have huge ideas.
Huge ideas.
huge ideas. Okay, now Smitty, actually Burke did come by and he gave us his little testing device. He called it was a DDO2
He's back.
thing.
Yes, 202.
Burke's back.
Looks like he's already disassembled it.
Burke has disassembled something. This is a model DS203. I guess this is how we're going to be testing our stuff. Oh, how do I turn it on? There's
We tried turning it off and on again.
the ONN-OFF discriminator is in the wrong position, Burke. So I guess, this would be the perfect way to calibrate it. So if you have a device that you trust like this, then I can adjust those the caps. What did you call them? Puff caps?
Trimmer caps.
The trimmer caps, so that I can get the right signal. I should see the exact same pattern on my oscilloscope as I have on this calibration device. And if it does, then I'm good.
You're going to need to send me a link for this, Burke, so I can throw it in the show notes.
Underneath the battery.
Why do you want me to look into the battery?
That's how you adjust that scope. That's how you calibrate.
Oh, so I calibrate this scope with this. So what I'm going to do before I give it back to Burke
Is
I'm going to change everything.
Yep.
Because I'm a bad person.
Push all the buttons.
Burke, take this back
Because
before
you're a jerk.
before I mess it up. Thank you. All right. So we've got a description of what the pieces do, which is what we want.
Yeah.
That's why we brought you on. Thank you very much, Smitty. But now let's talk about some practicals. This is not the best soldering station, but for the money, this was what, $60? This actually does really well. It's fully adjustable. It's got a reflow station.
I was going to say, that's a rework iron. What is that?
I know, right? Yeah.
Yeah.
How much was it?
This was 60-some bucks.
Holy cats.
I know, right?
And you've been using it for a while, too.
I've been using
so
it.
it's
Yeah, this
not
thing
like
is a year and a half, and it's going strong. I've been using it
Wait,
almost
but that's
daily.
got a built-in power supply, too.
Built-in power supply and a voltmeter, and it's all digitally controlled, so I can tell it exactly what temperatures I want for when I do my soldering and my reflow.
Make sure the link to that's in the show notes.
Yeah.
Okay.
Yeah.
That is...
It's actually pretty
okay.
spectacular. I didn't think you'd be able... I thought it was going to be cheap and it'll be dead within a month, but this thing has held on.
Nice.
Okay.
I figured.
Interesting.
But I've got a digitally adjustable heat source, and people have often asked me, well, what temperature do I want? So if I get one of these, it's not just a plug in and get heat. What temperature should I be soldering at, and what are the advantages of going hotter or cooler?
So I'm not going to be able to give you a number. The reason I'm not going to be able to give you a number is because I don't know. I use a Metcal, and Metcals are not adjustable. I bought a Metcal that was not working at the time back in the early to mid 90s. I don't remember exactly what year it was. Just so you know, Metcals at the time were going for about $1,000. Yep. You can get the Metcal that I have. It's a very old one. Obviously, I bought it in the mid 90s. You can get them now for about $300 or $400, and they are worth every damn penny. They are like soldering with butter. It's amazing. Anyway, mine didn't work when I bought it. I bought it for $20. I went down to the electronics junk store I was working at the time, Haltech, not Halted, Haltech up in the Bay Area, and bought a 20-cent transistor, replaced it, and got it working again. So that was the best $20.20 I've ever spent.
Right.
But in any case, the Metcals are not adjustable. You don't set the temperature with a knob. So I can't give you a number because I don't know what number it is. Having said that, you probably want to go kind of on the upper end of the mid-range. The more heat you do, the quicker you'll be able to get the heat delivered to the pad and the pin. And you want to be in and out as quickly as you can without rushing it. You want to make sure that the pad and the pin that you're soldering get hot enough for the solder to flow to it cleanly without having like all of that heat dissipating into the rest of the chip and the rest of the board. The problem with going too hot is that if you leave the soldering iron on there too long because you're working something or you have to move it around or whatever, then you risk burning things out.
Right, you will kill the component.
Yeah, so I don't recommend going as hot as you can. I've actually been listening. Can I mention other podcasts?
Of course.
It depends.
It depends. It's not a twit podcast. Ham Radio 360, and they've recently done a series called The Workbench. And George there recommends just cranking up the temperature on your soldering iron as high as it'll go and getting in and out as quickly as you can. And if you know what you're doing and can actually get in and out quickly, that works out really well. But for people who are just starting out, you probably want to back off from as hot as it'll go by a quarter of your dial or whatever.
Yeah, this has been one of the difficult things to figure out for newbies, which is they get afraid and they want to turn it down. They think if they turn it down, they've got more time to work. And as you said, no, because what it means is now you're sitting that iron on the pad for much longer. That's transferring much more of the heat into the board. That's when you start to smell fiberglass. And that's bad. That's bad.
Yeah,
you don't want to smell that. No. That's when you burn through the hole and you've just destroyed the pad. Then throw that away.
Right.
But on the other side, I'm happy with about 375 to 400 degrees.
Celsius or Fahrenheit?
Celsius.
Okay.
Yeah, but if I go above that, then I
start burning things?
I burn components. I don't burn the board. I burn the component.
Yeah, the components are much more sensitive than the board.
Yeah. But I mean, if you are a master and you can be in and out, in and out, in and out, oh, that's awesome. That's fine. All right, so I think the proper answer for this is what you feel comfortable with. If you're not comfortable with this yet, start with a junk board. Look at desoldering and resoldering components. That kind of gives you an idea of what your comfort level is going to be. You want to be comfortable with this so that you're not always rushing the solder, but also you don't want to be leaving the iron just sitting on top of it.
Yeah.
I have made a couple of learn to solder kits for various different projects I've done. The Darknet, I've made some, although Crux took those over from me a few years ago. I've been doing them for some events at work as well. I really should make a learn to solder kit that I can make available to the public. That would be fun.
Well, that's what we're going to be doing next time. All right. We're almost out of time, but let's talk a little bit about this because we've done soldering on the show, but normally it's been soldering wires together or soldering a simple component onto a board.
Pretty basic.
We are doing an entire kit which has its own challenges. Now, one of the challenges at the beginning is how do I properly attach things? Like, for example, let's say I wanted to put this here. Now, you showed me the proper way to tack components, but when I go to flip this thing over, it's going to fall right out. So how do I deal? I mean, this sounds really, really basic, but people are going to run into this, Smitty. How do I deal with something like this?
So first off, first thing I'm going to tell you is do not put that connector in first.
Right.
The reason is because it is tall. It is physically tall. And so if you've got another component that's short right next to it, you now have to work around the tall thing to get to the short thing. I highly recommend starting with all of your low-level components first. Low-level meaning like physically short and close to the board. Your resistors, your inductor, the little green inductors. Any surface mount components. It looks like this one comes with all the surface mount already pre-mounted. But start with the short components and then go to the tall ones. And that will make it a heck of a lot easier to get in there. Having said that, once you put something into the board, one way to do it is flip it over, continue holding it from the bottom, and then just take a couple of the pins and bend them over. If the pin is thin enough to actually bend easily, some of the sockets and the pin headers are super thick and you can't bend them at all, so that doesn't work out. But if it's a thin enough component that you can bend the lead over, like all the resistors and capacitors and diodes and all of that, you can kind of bend the leads out a little bit, and that'll keep it from falling through the board as you're soldering it on the top side while the component is hanging off of the bottom.
You showed me a technique when we were doing the steampunk clock where what you would do is you would tack a pin, like tack a pin here, tack a pin here, and even if it wasn't completely flush, you could just reflow and then kind of move the connector until it was flush with the board. That's actually a decent way to do it, yeah?
Yes. So that's the other thing I was going to point out for like the pin headers where they're super thick, much thicker than the leads on your components, and you can't bend them very easily. And they're thick and short. They're not sticking up long, so you can't bend them out. What I'll do is I will hold it. This is where you need 3 hands, unfortunately. I will hold it from the bottom with one hand. I'll come in with a soldering iron on the other hand, and then I'll come in with a little dab of solder with my third hand. And actually, what I usually end up doing is I'll have like a helping hands hold the solder or just have it off the edge of the table. Okay. And then I'll come in, hold the component up from the bottom with the soldering iron, kind of move the whole thing in, give it a little dab of solder, pull it away, and just enough solder to hold that one pin in, which will hold the rest of the component. And then later on, you can make sure it's straight and make sure it's all in the right position and everything. And then from there, you put the rest of you solder the rest of the leads.
All right. Okay, now let's take this. So this is one of my lowest line components. This is a resistor, if you go to the side view here. Obviously, it's going to go into one of my slots that has a resistor number. I'm not actually going to solder this right now, but if I have a component like this and I need to put it into this, obviously I'm going to have to bend the leads. Is there a right way to do this? Is there a wrong way to do it? Or as long as it fits, who cares?
It's pretty much as long as it fits. Who cares? Resistors are not polarity sensitive, so it doesn't matter which way it goes in. It depends on how the board is laid out and how big the resistor is. Sometimes you need a gradual curve on the pin because the holes are far apart. Sometimes you need to bend those pins really close to the resistor because the holes are very close to each other.
Yeah, I was going to ask about that. When I'm talking about bending, is there an inappropriate way to do this? Do I want a right angle?
No, it doesn't matter. You just don't want to bend it too often because they will fatigue and break eventually, but it takes a while for that to happen.
Okay, now on the other side, of course, I've got a huge lead because that's how that works.
It's huge.
I don't clip this until the end. I want everything done before I start clipping, right?
Correct. So you pull them out a little bit and bend them. Don't make them go straight out of the board because then the resistor will just fall out again. If you bend them out a little bit so that they're kind of facing at like a 45 away from each other, that's your cue to bend the lead out. There we go. Yes. So now the component will stay in and you can solder the pads from the bottom side. So one side is the component side, one side is the solder side. The component's going to go on the component side and you'll solder from the solder side. And so now it'll stay in there while the board is facing down and you can solder from the top side without the component falling out.
Right. Okay, so one last bit before we call it a day because I do want time to assemble one of these. There's going to be some trickery. I'm actually going to properly assemble one of these before we do the next episode.
Okay.
So that even
one of those like cooking show things, like, and now that we
look
have
what we did.
Let me just pull it out of the oven.
The magic of television.
I know. Yeah. It doesn't matter that I soldered 3 of those components backwards. It totally works, Brian.
Totally.
But is there any special thing that I should know going into assembling a kit like this where there are multiple components? What do you do to make sure that you're always putting the right component in the right place? Is there some sort of mental checklist that you use? Is there some sort of mnemonic? I mean, get me into the mind of Smitty here.
Well, okay, I don't think of a mnemonic, but I look at all the short components, so typically resistors and some of the smaller capacitors, and I just pick up a resistor, I pick up a component. So, okay, some kits will have you assemble it in a certain order, like we're going to do the power supply section first, and then we'll test the power at the various different places and make sure it's good. Then we'll do the analog part of it, which is kind of resilient to certain things, and we'll test that. And then we'll put the digital stuff in. And sometimes the instructions will have you do that. If the instructions are just here are the parts, here's the board, go, then yeah, do all the low-level stuff first. And then just go to the taller and taller and taller components as you go along. I just pick up a component of the right height that I'm working on right now. I'll just randomly grab a resistor, figure out what its value is, figure out a spot on the board where that goes, put it in there, solder it, grab the next resistor, figure out where it goes, put it in, solder it, so on and so forth. Lather, rinse, repeat until you're done.
Yeah, because if you follow the instructions, it says start with the resistors, and then there's actually, like, we're going to have to really look close.
No, seriously, yeah, you have to look very, very, and because we're not Smitty, we can't tell the resistance from the band, so we're going to have to look at a picture to make sure each of these match up.
Yeah, because there's a lot of different ones.
Black, brown, red, orange, yellow, green, blue, purple, gray, white.
Stop it.
Black, brown, then the colors of the rainbow, then gray, white. That's all you have to remember.
Oh, well, okay, I got it.
I'm not going to tell you the other way to remember because that's completely inappropriate.
Okay.
It'll probably be easier to remember.
Off the stream.
It probably will be, but I will tell you off screen. It is not appropriate.
All right, Smitty, thank you so very much.
Absolutely.
Can we have you back because we are actually going to need your help when we need. Brian and I are both going to be soldering simultaneously. That's right.
Yeah, anytime I'm available anyway.
All right. Smitty Halibut, he's actually been on the Twit TV network many times. You've been on a Triangulation, you've been on Coding 101, you've been on Know How, you've been on Try It.
I still need to get you on Ham Nation at some point. That's all me. I got to schedule that with you. So.
All right, make it happen.
But, my friend, you've always had an issue whenever you come on the Twit TV because you don't have anything to promote on your own.
I haven't had anything to plug.
You do now.
Until now, I have been streaming. I looked at Twitch, not This Week in Computer Hardware, but like Twitch TV, the streaming service, and I'm thinking, what? People are watching other people play games? Why in the heck would they do that? Maybe people want to watch me doing my hobby, which is laying out circuit boards. So I tried it. And I now have a YouTube channel called Smitty Working on Something. Go to YouTube and search for Smitty Halibut, SmittyHalibut, and you get to watch me do my electronic stuff. Right now, I'm working on what's called the Halibut amp, which is a headphone amplifier. It's kind of a very specific functional design. I'm not targeting the audiophile world, so all of you audiophile headphone amplifiers, don't worry, I'm not coming after you. I'm going after a very specific use case. Watch the first episode in that playlist. We'll go ahead and include links in show notes if you want for that. But yeah, so I've been doing that kind of stuff, and I interact with folks who are watching me while I'm doing the live stream, answering questions. Actually, just the stream I did yesterday, Robert had noticed a bug that I did and fixed it and pointed it out to me in the chat room, and so I fixed it, and that was really kind of handy. So yeah, Smitty Halibut on YouTube.
And actually, Smitty and I will be doing a show together on Twit. It's called Smitty Says Bad Job. And it's just Smitty,
it makes you cry.
It's just Smitty shaking his
Isn't
head.
that what we're doing now?
Bad job.
That
bad.
pretty much is the
Bad.
show.
It's a bad
Those
job,
are not
and you should
regulators,
feel
Padre.
bad.
Should that
Those
be
are
the,
not those are not regulators, Padre. That's a socket.
I know.
should that be the title for today's episode? Like,
Those
Smitty
aren't
makes you cry?
regulators.
Yeah.
No, actually, can we do an animated GIF for Smitty when he's just like,
Just shaking his head.
no, bad job, bad job. Smitty, thank you so very much. We're going to put this thing together. We're going to be doing it, Brian and I, at the same time.
Nice.
And then you can say bad job.
Yeah. Make us cry to get in
No, because
tandem.
it'll work. It'll work, and I'll say you guys are awesome.
And also because I'm going to have the one that's pre-assembled under the table and go, oh, look.
That's right.
It's
It's
amazing.
great, right?
Oh, folks, we know that this has been a long, long episode. Actually, we are over time. And thankfully, we've got show notes. If you want to find out anything about the oscilloscope, if you want to find out about what Patrick and Norton and I talked about CES, you're going to want to go to our show notes. And where did they find those, Brian?
You can find those at twit.tv/KH, and we'll have a list of all the parts of things that we use, the kits, Smitty's information, which please email me any of that after the show, Smitty. And if you've missed an episode, make sure to subscribe or download.
Oh, and Brian, I'm going to say this in the show, even though I really want it in the notes. Be sure to give them the link for the Yeehaw.
Yeah.
Yee-hoo.
The and Burke's thing that he brought in. So we're going to have a lot of stuff in there.
And don't forget that you can also find us on the socials, primarily on Google+. If you go to Google+ and look for Know-How, there's a little application process, but everyone gets through. It's just to keep out all the spam accounts. You'll have access to almost 11,000 teachers. That's our know-it-alls. And those are experts, intermediates, and noobs. No matter where you are, no matter what you've been doing, no matter how much knowledge you think you have, there's always something for you. If you're an expert, help the people who are new. If you're new, listen to the experts. And if you're an intermediate, why not come in and drop off ideas for projects or maybe pick up a few yourselves? Post some videos, post some photos, and we'll get you into an episode of Know-How. I promise. I know we haven't done a feedback episode in forever, but we're getting there.
Sooner or later.
Yeah.
But if you want to see what we're doing, like we just got back from CES. We had a lot of pictures and things that we took while we were at the event. You want to maybe get in touch with us directly, because I really have trouble replying to people's emails. You can follow me on Twitter at cranky_hippo.
And you can find me at PadreSJ. And you can find the third member of our community, he's got his button.
He lurks in the darkness.
He's got his finger on that mute button right there.
He's ready.
But I won't use his address because he doesn't like it when I use his address when I say an L3. Yeah, just go to Twitter, look for an L3, and say hi to Alex. He's a good man, Alex Gumbel.
There's nothing interesting there. Just don't do it.
Yeah, don't do it. Okay. Until next time, I'm Father Robert Ballasare.
I'm Brian Burnett.
And that is Smitty Halibut. He's our electronics guru. And now that you know how,
go solder it. Or build it. But we haven't yet.
we're doing that next.
You're gonna.
We're gonna.